How does a single individual simultaneously dictate the bleeding edges of artificial intelligence, humanoid robotics, and orbital space exploration? A standard chief executive typically spends their entire career mastering one specific industry. Elon Musk operates at the apex of several entirely distinct sectors. By June 2026, the cumulative market value of those overlapping enterprises pushed his personal net worth past $1.1 trillion. His physical infrastructure stretches from 200,000 GPU supercomputers humming in Memphis and automated Neuralink surgeries in clinics to vast Starlink constellations overhead and sprawling Tesla manufacturing floors. Looking at this immense scale, the question is whether we are witnessing an overextended industrialist or a highly deliberate interconnected machine operating exactly as designed. The financial reality of that machine snapped into focus with the 2026 SpaceX IPO. Raising $75 billion, it immediately became the largest public offering in capital markets history. Look at this chart comparing aerospace valuations. The public PPU assigned SpaceX a staggering $2.1 trillion valuation, dwarfing legacy competitors combined. The math behind this is driven almost entirely by Starlink, pulling in $3.3 billion in Q1 2026. Parallel to that commercial success is a classified military offshoot known as Starshield. Currently operating over 183 custom-built satellites, it provides target tracking and reconnaissance specifically for the US Space Force and national intelligence agencies. SpaceX provides the foundational infrastructure for global orbital defense and secure government communications. While that orbital network scales, an equally aggressive expansion is happening on the ground. In Memphis, xAI transformed an abandoned factory shell into the Colossus supercomputer in exactly 122 days. This visualization illustrates the immense physical footprint of that facility: 200,000 interconnected H100 GPUs drawing 250 megawatts. Maintaining this is a battle against physical decay. Training Grok 3 triggers volatile power swings, and a single cosmic ray bit flip can corrupt an entire run. Winning the AI race now centers on a logistical mastery of hardware, liquid cooling, and enormous electrical generation. That hardware mastery extends directly to Tesla, raising a serious debate over whether it should still be evaluated as an automaker or as an applied robotics firm. The first quarter of 2026 saw the official start of production for the fully autonomous Cybercab, rolling off the line at Gigafactory, Texas. This chart tracks cumulative paid robotaxi miles, and it shows a steep exponential upward curve as unsupervised rides rapidly expand across major metropolitan areas. Simultaneously, the company began pilot operations of Optimus Gen 3 humanoid robots, inserting them into the Fremont and Austin factory floors to handle repetitive sorting and assembly tasks. Tesla's long-term valuation is tied to its ability to scale autonomous labor and replace traditional transit with a software-driven fleet. The SpaceX IPO prospectus cites a total addressable market of $26.5 trillion for AI applications. This figure reflects the move toward high-density computing that terrestrial infrastructure is struggling to support. As Earthbound data centers hit limits on land use and cooling, orbit offers a specialized alternative. Space provides a natural heat sink and direct 24-hour access to solar energy for massive GPU clusters. Instead of battling terrestrial power grids, the architecture moves to high Earth orbit. Tens of thousands of processing nodes drifting in a vacuum, sharing intelligence. The long-term expansion of artificial intelligence relies on accessing these orbital resources to bypass the physical constraints of the Earth's surface. When you analyze the capital and the engineering moving between these entities, a central question emerges. Are these separate businesses or components of a single machine? The links are highly explicit. On the Tesla factory floor, those Optimus humanoid robots process spoken commands by routing data through xAI's Grok voice interface. In Memphis, the massive electrical load required to train those xAI models is actively stabilized by giant banks of Tesla Megapack batteries, absorbing the system's chaotic power swings. And on the road, Tesla's unsupervised Cybercab fleets maintain constant global connectivity by beaming their telemetry straight up to SpaceX's Starlink satellites. Energy generation supports artificial intelligence. Intelligence controls physical labor, and an orbital network connects it into a How does a single individual simultaneously dictate the bleeding edges of artificial intelligence, humanoid robotics, and orbital space exploration? A standard chief executive typically spends their entire career